Hey, this video is on integration using tables. And the first problem that we will look at here is the integral of x to the power 4 divided by the square root of x to the power 10 minus 8. I'm going to start this problem by just making a simplification to my expression here. I will write this as the integral of x to the power 4 divided by the square root of x to the power 5 squared minus 8 dx. And so what I would like to do actually is do the u substitution first, and then I'm going to go look for a table formula that might work. So for this problem, I think I will let u be equal to x to the power 5, which means du is equal to 5x to the power 4 dx. I do see that I have a x to the power 4 dx in my problem, so I'm just going to move the 1 over 5 du to the other side. And also in my problem, I'm going to let a be equal to the square root of 8. And so we can actually come over here and write this as the square root of 8 squared. All right, so we can now make a substitution. And this will become 1/5 times the integral of 1 over the square root of u squared plus a squared du. So I'm going to need to go find a table formula that works. I've already looked at my table formulas and I found that table number 43 is the correct table formula to use here. This will be equal to 1/5 is my coefficient that needs to be distributed throughout. And then I will have the natural log of the absolute value of x to the power 5 plus the square root of x to the power 10 minus 8. Close absolute value. And we can put our plus c on this answer. All right, the next problem that I have here is the integral of sine of 2 theta divided by the square root of 6 minus 7 times sine theta d theta. So the first thing I'm going to have to do here, since we have sine of 2 theta and sine of theta, I'm going to use a double angle formula. And the one I will use actually is going to be sine of 2 theta is equal to 2 times sine theta cosine theta. And I'm just going to rewrite my expression. And so this will be the integral of, I'll make this a little bit bigger, a little more room. The integral of, so this will be 2 times sine theta cosine theta divided by the square root of 6 minus 7 times sine theta d theta. All right. Again, for this problem, I think it may be helpful to do the u substitution first before we go and try to find a table formula that works. This problem actually does provide me with a short list of formulas to choose from, and here is the list that it provides. But let's go ahead, like I said, and just do that substitution first. So for this problem, I think that the correct thing to do is to let u be equal to sine of theta. So if u is equal to sine of theta, then du will be equal to cosine of theta, d theta. For this problem also, I'm going to let a be equal to 6, and I'm going to let b be equal to negative 7. So the substitution then is going to yield 2 times the integral of u over the square root of 6 minus 7 times u du. And I think now we can go look for a table formula that might work. So out of our short list, it looks to me like table number 55 is the one that's going to match my problem. Right? So we can go ahead and replace also here the a and the b in our expression. All right. So evaluation now is going to yield, let's let that fit in. This will be 2 times 2 divided by 3 times 49 times -7 sine theta minus 12 times the square root of 6 minus 7 sine of theta. And I'm going to just simplify this just a little bit. This will give 4 over 147 times -7 sine theta minus 12 times the square root of 6 minus 7 times sine theta plus c. All right, I do have one last problem here. This problem says use the table of integrals to evaluate the integral of 3 times secant square of theta times tangent square of theta divided by the square root of 49 minus tangent square of theta. So if you would like, we could rewrite this. Actually, just write it down here. We could write this as 3 times the integral of, I'm going to write this as tangent of theta, quantity squared, divided by the square root of 7 squared minus tangent theta squared. And then I will put the secant squared theta d theta out here. All right, so for this problem, I'm going to let u be equal to tangent of theta. So that it will follow then that du is equal to secant squared of theta d theta. That works out very nicely because this is already in my problem. And I'm going to let a be equal to 7. So when I make this substitution, my integral will have the form 3 times the integral of u squared divided by the square root of a squared minus u squared du. And now I'm going to look through my table of integrals to see if I can find a table that matches. I actually do. Table number 34 is the correct table to use. So this integral will be equal to 3 times negative tangent of theta over 2 times the square root of 49 minus tangent squared of theta plus 49 over 2 times sine inverse of tangent of theta divided by 7. And again, if you would like to make this one last final simplification, this constant 3 can easily be distributed, and this will give -3/2 tangent of theta times the square root of 49 minus tangent squared of theta plus 147 divided by 2 times sine inverse evaluated at tangent of theta over 7. And then do not forget that plus c on your final answer.